Hey there, class. Today we're going to be doing Chapter 10, Section 3 on arcs and chords. We've talked about arcs and chords in the last couple of sections, so refer back there if you're not quite sure. Our objectives today are to recognize and use relationships between arcs and chords, and then to recognize and use relationships between arcs, chords, and those diameters. So let's go ahead and jump right in with a theorem. It says, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if we say that FG is congruent to JH, so these are chords, so if FG is congruent to JH, then the arcs are congruent. Then arc FG is congruent to arc JH. And we can go reverse. If the arcs are congruent, then the chords are going to be congruent. All right, in the embroidery hoop, our AB is congruent to CD, and the measure of arc AB is 60. Find the measure of arc CD. Well, if the chords are congruent, their arcs are congruent. So we can say it's just 60 degrees. All right, in the figures, the circles are congruent and the arcs are congruent. Find PQ. So if the arcs are congruent, the chords are congruent. So we're just going to go ahead and set those two chords congruent. And you can solve for X, but remember, plug that back in and find PQ. So finish that up, and we'll talk about it in class. In circle W, so now we're talking about the same circle, RS is congruent to TV, find RS. So we can set those congruent, and we need to solve for X. So if we minus that over and add the 9, we get 12. So here we get X equals 4. Yet our problem asks us to find RS. RS is equal to 5X minus 9. So in place of X, we're going to put in that 4 we just found. So we get 20 minus 9, so RS is going to equal 11. All right, next theorem. If a diameter or a radius of a circle is perpendicular to the chord, then it bisects the chord and the arc. So what we're looking for here is that 90-degree marking right there, because that's telling us that our diameter and that radius are bisecting the arc and the chord. That doesn't mean that the chord is congruent to the arc. It means the two parts of the arc are congruent and the two parts of the chord are congruent. All right, so on the back side of the note, we can go the other way. If it's a perpendicular bisector, so 90-degree angles, and it split those into two congruent pieces, then it's a diameter or a radius of the circle. So in circle S, the measure of arc PR or PQR is 98 degrees. Find arc PQ. So we know that this whole thing here is 98. Well, because we have a perpendicular, it's going to bisect. So we want to take 98 and divide it by 2. And that is going to be our measure for PQ. So go ahead and type that in on your calculator. And we get 46 degrees. All right, so it says in circle S, find PR. Well, again, perpendicular bisector. So these two parts of the chord are going to be congruent. So looking at that information, you come up with how long is the whole chord PR. All right, in circle J, the diameter is 30 inches and KM is 22 inches long. Find K or JL. All right, this one, we're going to see these quite a bit throughout the rest of the chapter. It's a little tricky, so you need to really, really pay attention to what's going on here. Okay, so KM is 22 inches long, so that means that this whole piece here is 22 inches long. So I see a perpendicular, and so that means it bisects it. So we have an 11 and an 11. It also tells us the diameter is 30 inches. So that means our radius is 15. So diameter is 30 and a radius is 15. Well, we have a radius here, and that is going to be 15. Now, JL is just part of that radius, but we don't know quite yet how much, if it's bisected or not. But if we look here, we have JK. JK also happens to be a radius, so we can put 15 there. Now we need to find JL. What have we just created there? A right triangle, good. So we're going to go ahead and we're going to write this all out here. And we need to find that distance. So I'm sorry for my poorly drawn right triangle. Go ahead and do Pythagorean theorem to find us what JL is going to equal. All right, in theorem 10.5, it says, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So this chord here and this chord here are, oh, sorry, let me try that again. Those are going to be our equidistant, and they are going to make our two chords, FG and JH, congruent if they're equidistant. All right, and because we see a perpendicular, it's going to bisect these two pieces. And if they're congruent, these two pieces are going to be also congruent. And then again, the two arcs are going to be congruent. So we have a lot of congruency going on because those two pieces are equidistant. So go ahead, let's look at this last problem. In circle A, WX is congruent to XY, and that's 22. So this chord is congruent to this chord. So if those two chords are congruent, then we know that our distances are going to be equidistant. So go ahead, we're going to set 5x equal to 3x plus 4. Solve that for x. So we have 2x equals 4, so x equals 2. So that's not quite our answer though. It says find AB. So go ahead and plug that back in to get us AB. And the segment AB is going to equal 10. And just so you know, if you were to plug the 2 back in over here, we should also get 10. All right, finish up those missing problems and we will go through them